Machining is a manufacturing process, in which a piece of raw material is cut into a desired final size and shape. Such processes, like turning and milling, are also denoted as subtractive manufacturing since they are fundamentally carried out by means of material removal. This experiment aims to examine the cutting forces in a turning process. The theoretical background on orthogonal cutting is to be verified by machining experiments on a lathe. This picture reveals the conventional lathe in the machine shop, at which the orthogonal cutting tests were carried out. Two strain gauges are glued on the two bending surfaces of the tool holder, to detect the strains on those axes. The strain indicator and recorder device was utilized to measure the deflections at the instant of cutting and feeding. Consequently, main cutting force and the thrust force components are determined by the conversion from the deflections to the forces, using beam bending theory. The experiment begins with the setting of the turning parameters, such as rotational speed of the spindle and the feed of the cutting tool. Spindle speed and the feed rate could be adjusted by various configurations of the levers shown in this picture. Before the cutting, the initial diameter of steel workpiece is measured by a caliper. Then, the operator starts the spindle and performs the cutting with a constant axial feed. At the time of machining, the strain values of the tool holder caused by cutting force and axial force are recorded. After the cutting, final diameter of the cut portion and dimensions of the produced chips are also measured. At the end of the experiment, the recorded strain values are ready to be converted to the relevant force components.